42, I'm on page 198. Okay, 42, they want us to find f prime of 2. Okay, they give us given, okay, f of 2 is equal to -1, f prime of 2 is equal to 4, g of 2 is equal to 1, and g prime of 2 is equal to 5. Right. This is not that hard, so let's do a couple of these. Let's do A first. So they tell you f of x is 5 times f of x, small f of x, plus 2 times g of x. This type of problem shows up on the multiple choice on the AP test. It's fairly easy. So first you're going to find f prime of x, which is 5 times, that's my coefficient, so 5 times f prime of x plus 2 times g prime of x. Okay, to find f prime of 2, that's what we're trying to find. This is going to turn into 5 times small f prime of 2 plus 2 times g prime of 2. Then you're going to go 5 times, we're going to find f prime of 2, which is 4, plus 2 times g prime of 2, which is 5, okay, which is going to give me 20 plus 10, and the answer is 30. Alright, let's do C. You'll get the idea, it's not that hard. C is f of x is equal to 2 times small f of x times g of x. Alright, when I take the derivative of this, my 2 is just a coefficient. So f prime of x is going to be 2 all that times. I'm just going to pull the 2 outside to get it out of the way. This is a product, so that means I'm going to use product rule. First times derivative of the second plus second times derivative of the first, and that is the derivative. Now we have to find the derivative at 2, so we're going to plug in 2, so f prime of 2 will now be 2 times f of 2 times g prime of 2 plus g of 2 times f prime of 2. Okay, now we just have to go find all the values and plug them in. F of 2 is -1, g prime of 2 is 5, plus g of 2, which is 1, times f prime of 2, which is 4. If I clean this up, I have a 2 times -5 plus 4, which is going to give me -1 in the brackets, which is going to give me -2 as my final answer. Okay, so that's how number 42 is done. So let's do 44, which is the next problem I want to do for you. So 44, you're given y is equal to 1 minus x, all that over 1 plus x. And they want us to find the equation of a tangent line to the curve at a given point at x is equal to 2. So if you want to find the equation of a tangent line, you need a point and you need a slope. So we have 2 comma something, we don't know what that is, so we're going to plug in 2 into the function, which is going to give me 1 minus 2 all that over 1 plus 2, which is -1 over 3, so -1/3 is the point. The next thing we need to find is y prime. Okay, y prime of x means the derivative, which means I have to use the quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all that over denominator squared. Okay, we have to plug in 2. Don't simplify, just plug it in, then simplify. So when you plug in 2 every place you see an x, this is going to give me 3 times -1 minus -1 times 1, all that over. Okay, 2 plus 1 is 3, so 3 squared. So if we clean this up, it turns out to be negative 3 plus 1 all that over 9, and this simplifies to negative 2 over 9. So this is my slope. Okay, I have my point and I have slope. How do I find the equation of a tangent line? Simple. Y plus 1/3 is equal to negative 2 over 9 times x minus 2, and that's it. That's the equation of a tangent line. Alright, let's do 46. Okay, this is 46. Let's do 46a first. Okay, 46a says y is equal to 4x to the 7th minus 5x to the 3rd plus 2x. And they're asking me to find, okay, d squared y over dx squared. This means to take the second derivative, or f double prime of x, or y double prime. Okay, first of all, we're going to take y prime. That means we're going to take the derivative of this. So that's going to give me 28x to the 7th, okay, minus 15x to the 2nd plus 2. That is my first derivative. Okay, so then I am going to take the second derivative. Okay, so my second derivative will be 7 times 28, which is 196. Okay, 196 x to the 6th minus 30x, and that's it. That is my second derivative, and that's all they want me to do. Okay, so we take a derivative, we take it again. So let's do c. The reason I want to do c is there's a hard way of doing this, and there's an easy way of doing this. Okay, so whenever you can simplify using algebra and then take a derivative, it's easy. So let's simplify this. So this is 3x over 5x plus, minus, okay, minus 2 over 5x. So if we clean this up some more, this is going to give me 3 over 5 minus 2 over 5x to the negative 1. Okay, that's cleaned up, so I can take a derivative. Okay, the derivative of 3/5 is just 0. When I take the derivative of this, I'm going to multiply by the coefficient, so it'll be positive 2 over 5x to the negative 2. Then I'm going to take a second derivative, which is going to give me negative 4 over 5x to the negative 3. See how easy it is if you simplify using algebra first. Okay, when you have to take multiple derivatives, okay, you're better off, simplifying first and then finding a derivative. Okay, so let's take a look at the next one. I want to take a look at is sine 73. So let me do number 74a. Okay, and then we'll do a hard one after that. So 74a. Okay, so they write it like this: d dx, and in the brackets they have a x to the negative 5 times x squared plus 2x times, I have a 4 minus 3x times, I have a 2x to the 9th plus 1. Okay, they want me to take the derivative of this. Of course, okay, we can multiply all this out and then take a derivative of this function, or there's an easy way. This time it's probably just easier to not do the algebra, okay, and then just take the derivative. How do you do that? You take the derivative first, okay, which is negative 5x to the negative 6, and you leave the rest of it alone. X squared plus 2x, 4 minus 3x times 2x to the 9th plus 1, and then plus. Now this time we're going to take the derivative of the second one, leave everything else alone. X to the negative 5, we'll leave that alone. Take the derivative of the second one, which is 2x plus 2, and then leave everything else alone. 4 minus 3x times 2x to the 9th plus 1. Okay, then plus. Now we're going to take the derivative of the third, okay, third one, and then leave everything else alone. X to the negative 5, I have x squared plus 2x, and when I take the derivative of the third term here, I'm going to have a negative 3, okay, and leave 2x to the 9th plus 1 alone. Plus. Now I'm going to finally take the derivative of the last one, okay, and leave everything else alone. X to the negative 5 times x squared plus 2x times 4 minus 3x, and then when I take the derivative of the last one, we'll get 18x to the 8th, and that's done. Okay, so we just keep taking the derivative of each one, leave the other ones alone, and then that is the derivative. If you want to simplify, you can. I strongly suggest you leave it alone before you make any mistakes. Alright, now here's an important problem that shows up on the AP test, and this is 76. Okay, they give us a piecewise function. So if it shows up on AP test, a good chance you're going to get a problem like this on the quiz. So x squared minus 16x when x is less than 9, and then you have 12 times rad x when x is greater than or equal to 9. Okay? Now, what they want is, they want to know if f is continuous at x equal 9, determine whether it's differentiable at x equal 9. So if so, find the value of the derivative. First of all, you have to check for continuity. Okay, how do you find is f of x continuous? Okay, actually continuous at 9. That's the question we have. To do that, we have to check the limit from both sides. Okay, so limit as x goes to 9 from the left side, and that's going to be x squared minus 16x, which means 81 minus 16 times 9. Okay, so 16 times 9, that is 144. Okay, and then when you subtract those two things, and that's going to give us 63 negative. Now I got to check the limit from the right side. Limit as x goes to 9 from the right side, and that is 12 times square root of 9, okay, which is 3 times 12, okay, which is 36. Okay, so it's not continuous. Okay, not continuous. So therefore it is not differentiable. Okay, so the game's over. If it's not continuous, it's not going to be differentiable. Okay, now let's see if we can do another problem where the function is continuous and differentiable. So let's go to number 76. So better do one more, or 78. Okay, so in this one, my f of x is x to the third, okay, plus 1 over 16 when x is less than 1/2, and then it is 3/4, okay, x squared when x is greater than or equal to 1/2. Okay, now in this one they ask me, okay, if this is differentiable at x is equal to 1/2. Okay, if it is differentiable, that means if I can take a derivative, I need to be able to find the derivative at 1/2. So if it is, then I got to find f prime of 1/2. First, I got to check for continuity. Okay, first is f of x continuous at x is equal to 1/2. How do I do that? I take limit as x goes to 1/2 from the left side, which means I use the top one. That means x to the third plus 1 over 16. and that is going to be 1/2 to the third plus 1/16, which is 1/8 plus 1/16, which is going to give me, this is 2/8 2/16 plus 1/16, so it'll be 3/16. Then I got to check from the right side. Limit as x goes to 1/2. Okay, from the right side, that means I have to use the second function, 3/4 and 1/2 squared, and that's going to give me 3/4 times 1/2. Oh, I better write the function down first. I'm getting ahead of myself. Okay, so I don't want to get ahead of myself, so I need to put x there. That's the function I'm using. So I'm going to get 3/4. I'm going to have 1/2 squared, which is 3/4 times 1/4, which is 3/16. So far so good. So the limits are the same. Okay. Now I have to establish what is f of 1/2, which means I got to use the bottom one, which is 3/4 because of the equal sign there. Okay, 3/4 to the 1/2 to the second, which is 3/16. Now, what this means is, therefore, my f of x is continuous at x is equal to 1/2. Okay, I'm not done yet. That's only half of the problem. Now, I'm finding the derivative at 1/2. So I have to actually take a derivative of this piecewise function. Okay, so my f prime of x is, okay, when I take the derivative of the top one, the first one, I'm going to get 3x squared, and that's when x is less than 1/2. And then when I take the derivative of the bottom one, I'm going to get 6/4 x, or 3/2x, and that is when x is greater than or equal to 1/2. Okay, I have to play the same game again. Okay, first I got to check for the limit as x goes to 1/2 from the left side. I'm using 3x squared, okay, which means 3 times 1/2 to the square, which is going to give me 3/4. Then I got to check the limit as x goes to 1/2 from the right side, which means I'm going to use 3/2x, which is going to give me 3/2 times 1/2, which is 3/4. Okay, so they're the same. And then I also have to find, and I need to, okay, I have to find, and this is going to 1/2. So I have to find f prime of 1/2. So f prime of 1/2 is 3/2 times 1/2, and that means it's going to give me 3/4. Okay, so the limits are the same, and the value of the function is 3/4. That means this tells me it's continuous, okay, and that means it's differentiable. So therefore, that f prime of 1/2 is 3/4. So first I got to check for continuity. If it's continuous, then I take the derivative, and then I play the same game. Okay, checking the limits from both sides, and then I got to find the derivative at that point. Now, if anywhere in this whole process it fails, the values are different, then the game's over. Okay, that's it.